Bismillahirrahmanirrahim. Today I'm going to explain the applications of coordination compounds, how the coordination compounds are useful in our routine life, in our daily life, how they have influenced various aspects of human life. The coordination compounds are important uh, as far as the medicinal aspect is concerned. They are being used in a number of industries, like they are a part of dye industries, especially metal based dyes have been produced. They have been widely used for the dyeing of the cellulosic fibers, for the textile materials, in fact nylon spools, etc. So I'm going to explain the coordination compounds. Before that, I've given you last time a lecture giving you a brief intro about the coordination complexes, coordination compounds. Let me explain a bit briefly what they really are. I've explained to you guys in my last lecture that the coordination compounds mean there is supposed to be central metal atom. Why metal atoms? We have an idea that metals are electron deficient. They need electron. They can accept electrons. Then we have certain bodies around the metal. We call them ligands, and we mark here as L's. I'll do specify ligands. Ligands are those entities. They could be the atoms, or they could be the group of atoms. They could be neutral entities, they could be anions. Why they are anions? Because we need somebody who has electrons, who has the ability to donate electrons. So somebody having negative charge, anions, they have the ability to donate electron to the central metal atoms. Or we have those atoms or group of atoms really which can donate electrons to the central metal atoms. The resultant compound, where we will have a central metal atom having coordinate covalent bond with the ligands, that compound will be called as a metal complex, coordination compound, coordination complexes. This is how they are supposed to be. Then I moved on. I put in some real examples there. I brought in iron. I showed you its bonding with water molecule. We have an idea in the water, the oxygen has the ability to donate lone pair of electrons. So this is how we can see that this will become as a complex or coordination compounds metal. Then we have a ligands over here. The ligands which, like say this oxygen has lone pair of electron that can be donated to the central metal atom. Similarly over here we have a lone pair of electron donatable to the metal atoms. Again lone pair of electron donatable to the central metal atom. It has been donated, that's why there is a bond between the metal and the oxygen. Due to the donation of this lone pair to the metal atom, a bond has been created, coordinate covalent has been created. Once the ligand gives provides lone pair to the central metal atom. Such bonds are called coordinate covalent bonds. This is one of the example where ligands are neutral group of atoms. Yeah, H2O is a group of atom, and at the moment it's a neutral as well, because the water molecules are supposed to be neutral. What is the extra ability they do have? They do have lone pairs at the oxygen, and those lone pair could be donated to somebody who needs electron. At the moment, that is the central metal atom. So this is one of the example of the coordination compound where we have a central metal atom and attached to the ligands, and the ligands are neutral group of atoms at the moment. Same sort of compounds could be generated as well. Let's say you can have a central metal atom, you can have certain atoms who has the ability to donate electrons. At the same time, you can have cyano groups, CN negatives. After connection they will come CNs. We do have the CNs are supposed to be like, if we have this body as, or we have something like that, it's supposed to be the negative entities, and those negative entities could act as a ligands as well. In the same molecule, one can bring ammonias as well. We have an idea the nitrogens do carry lone pairs. So a coordination compound could be like this as well, where all ligands are not of the same symmetry. In the previous examples, I put water molecules, all water molecules around the central metal atom, and I tried to show you that those ligands have the ability to donate electron. Yes, that is true. But the complexes could be of the other types as well, where we have atoms, we have anions, we have neutral entities, they have mixed together. That's also a complex where they are unsymmetrical, asymmetrical as far as the ligands are concerned, So this is how the metal atom is linked, covalently linked with the ligands, and the resultant compounds will be marked as coordination compound, coordination complex, So this is how it is supposed to be. Then, as far as I'm discussing at the moment, the coordination compounds of biological interest. Coordination compounds of biological interest. People have to prepare coordination compounds using organic ligands. The ligands are supposed to be the organic molecules, organic entities with such groups which have the ability to donate electrons, and they do link with the central metal atoms to their donors, okay, and they form coordination compounds. Then they are called organometallic compounds. Let me draw first the compound for you. Let's say for very convenience, I can write the other way so you can see the donation of electrons actually. We have an amine over here, we have an amine, we have an amine over here. So nothing has happened, the amines has been just written down over here, no problems at all, you people have an ideas. This is a chemistry. We can write them as per our convenience. Again, we have NH2s. I don't think so it's an issue for you. If people have better ideas. Then again we have an amine, we have CH2, we have CH2, and then we have NH2, okay? Means we have three molecules of diamines. It's a diamine, we have three molecules and we have a central metal atom. What could happen here? It can coordinate from here, it can coordinate from here. So a single ligand can coordinate through two positions, you know. Similarly, this body could have this one, this body could have this one. So, as the ligands are organic molecules, and when they are linked to the central metal atoms, they are linked to the central metal atoms, you know, they are called organometallic compounds as well. We call them organometallic compounds as well, you know, because organic compounds do coordinate with the metals. So organometallic compounds, they are the coordination compounds, they are the coordination complexes. You can call them organometallic compounds as well, and those organometallic compounds are of great biological importance, you know. That will be topic of my next talk, inshallah. At the moment I'm trying to give you an overview about the coordination compounds. Today what I'm going to give you lecture about the applications of coordination compounds, you know. So here I'm going to use coordination compound for the synthesis of, I'm going to prepare metal dyes, you know, metallic dyes. I will prepare metallic dyes using coordination compounds. Means dyes will be used as ligands and they will get linked with the central metal atoms. The resultant coordination compounds will also called as metallic dyes, metal dyes, you know. This is what I'm going to discuss.